Hello, so today we are solving two sum problem. So what this problem says is that we are given an array of integers and a target, and we need to return the indexes of the two numbers that sum up to the target. Like if we are given 2, 7, 11, 15, this is the array and the target is 9, then we need to return 1 and 2 because uh, 1 and 2 is the index of 2 and 7 and they sum up to 9. So you need to note that the array is one index based, and secondly that it is sorted. So we don't need to sort the array. Now if you see this example 2, 3, 4 and target is 6, we know that 4 and 2 sum up to 6 and their respective index is 1 and the index of 4 is 3. So they sum up to target and we return 1 and 3. In this example we return we know we have a target of -1 and the array contains -1 and 0, so we return 1 and 2 because -1 plus 0 is -1. So let's first discuss the solution and then we will code the solution as well. So I have taken the array here. Let me call this A. I have taken a sorted array and the target that we need is 9. So what we are going to use is a two pointer approach. So I'll take another color. What is a two pointer approach? So as we know with the name, it contains two pointers, like let me call them I and j. So these two pointers will point at the either end of the array, like I will point to the starting of the array and j will point to the end of the array. And the approach here we are going to use is we will sum up the values at the index. So let me call it current sum. CS, that is current sum, is equal to array of I plus array of j. Okay, so this is my current sum, and let me call the target that we need is equal to t. So target is 9. So if I sum the value that array of I at array of j, what I'll get? I get my current sum as 17 plus 2, that is 19, and my target is 9. So if you compare these two values, you know that 19 is greater than 9. Now we have two ways we can move this pointer. I can move forward and j can move backwards. So if I move I forward at this step, what I'll get at next step? I'll get 7. So I am getting 7 is greater than 2. That means if I add the value 7 and 17, I will get a greater sum, and that I don't want. I am currently having a greater sum than my target, and I want to lower my sum. That means I need to move j backwards. So this is the whole intuition behind this approach. So if I list down the cases, I have three cases here. That is my current sum and target. My first case is that my current sum will be greater than target. My second case is that my current sum will be less than target, and my third case is that my current sum will be equal to target. So the third case is the ideal case. That means that we have found a solution, and in this case we will simply return I and j. Because they will be the index that we want. They are summing up to the target and we can return I and j. If current sum is less than target, that means we need to increase our sum, and only way to increase our sum is to move I forwards. So in this case we will increment I by 1. And if our current sum is greater than target, that means we need to decrement j, and we will decrement j by 1. and we will continue this approach till I is less than j. Until I is less than j, we will keep checking the current sum and compare it with the target, and the moment I is equal to or greater than j, we can stop, because we know that we have traversed the array and we haven't found any such pair, so we can simply return an empty array. So let's try run this case once and check how we are getting the solution and how we are getting the pairs using this approach. So let me draw, this is I and this will be j. Okay, so initially I, j, current sum and target. Okay, so these four values we will consider. So I is 0 and j is, let me draw the index once for clarity. Okay, I is 0, j is 4. Now if I add 7, 2 plus 17, that is 19, and target is 9, that means our current sum is greater, that means we need to increment I. So next time I will move here, no, our current sum is greater, that means we need to decrement j, that means our j will move here and this will get removed. So next time we get 0, 3, and our sum will be 2 plus 15, 17, target is 9, we are still greater, so we will further decrement j. J will move here, j will move here, we will get 0 and 2. What is the sum? 2 plus 11 is 13 and current sum is 9, we are still greater, we will decrement j further, j will move here, that means 0, 1, 2 plus 7 is 9 and current sum is 9, so we can return from here the values of I and j, that is 0, 1. Now you need to see that since the array is one index space, so we need to first increment by 1 and then return. So this is the whole idea of this approach. I hope you got the basic understanding of this approach. Now let's code the solution once and see how it's all working. So we are given numbers, array and target, so I will take two pointers I and j. Now as we discussed, we will continue this loop until I is less than j. We will take a current sum that will be equal to numbers of I plus numbers of j, and we will check the three cases if CS is less than target, or CS is greater than target, and the last one is the solution case when CS is equal to target. In this case we will simply return I plus 1, since the array is one index space, so we will do plus 1 and then return. If current sum is greater than target, that means we need to reduce our sum, and only way to reduce is by decrementing the second, that is the j pointer. And if our current sum is less than target, that means we need to increment our current sum, and the only way to increment our sum is by incrementing the I pointer. And if we don't get any solution, we will return an empty array, but this shouldn't be the case as it is specified that there is only one solution. Let's run this and check if we are getting the solution. Oh, it will be else if. It's running. Let's submit this and check. Our solution is accepted. And an important thing to note about this is that the array should be sorted, because this approach works on sorted array only. If array is not sorted, then we won't be sure that if we move forward whether the next value is greater or lesser than the current value. We are only sure about this approach if the array is sorted. If the array is not sorted, then we need to sort it first to apply this approach. So if you see the time complexity of this approach, if we are given a sorted array, then it is O of n, because we are only traversing the array once. But if we are given an unsorted array, we need to sort it first, so that will take O n log n time, and then we are traversing the array, that is one pass. So O of n log n plus O of n effectively will be O of n log n. But since in this problem we are given a sorted array, so complexity of this is O of n. That's it for this video. If you like this video, please do subscribe to the channel. See you in the next video. Thank you.